Uh, so hello everyone, welcome back to my YouTube channel. So in today's video, we're gonna find out what's behind the DFS and the lowest common ancestor with short for with long for LCA to find the common ancestor between two nodes in the tree. So we're gonna use both of them in this problem. So this can be considered as a really hard problem. So but I will go along with you to solve this problem properly. So and prepare a drawing dashboard right here so I can visualize the tree and explain the algorithm applying both the DFS and lowest common ancestor algorithm altogether. So let's read through this problem statement. I think I can like summarize this, but it's kind of exciting. Like you can read with me. So I will read the problem statement. After being banned X, I don't know what is there, but okay, it's fine. The Leaf Village is currently in the process of rebuilding. So today, the Arcade of Leaf Village and some kind of name I want to say the last remaining member of Ocean clan are planning. So there's someone who is planning the reconstruction of the village, and the village is consisting of n houses, number from 1 to n, where the n is less than or equal to 2 multiplied by 10 powered by 5, and has n minus by 1 rows connecting any two houses. So in summaries, any houses in this village are interconnected with each other. So that means that there's always a road uh, going through any houses from one house to the second house. So there's always a possible road to do so, and each road gonna have a length of W, and W is less than or equal to 10 powered by 9. So because 10 powered by 9, so it's already uh, this is the limit of integer, so we're gonna use long here. By the way, we're gonna use the C++ programming language to solve this problem. It's kind of visual and efficient in this case. So we're gonna read the village now has three variables, where the p is less than or equal to 2 multiplied by 10 power by 5, consisting of three houses. For each triplet of these houses, these two guys want to calculate the minimum value of this function ax plus this function bs and the other of cx, and where this function uv is distant from the house u, the house letter u to the house letter v, where it is any house in the village. So for the input, we're gonna have the integer n, which for the number of houses in the village, and in each n minus 1 lies. So during the like inside the interconnected houses, there will be like n minus by 1 rows, so it will be interconnected. So let me write so you can imagine. So like this, uh, let's say this interconnected uh, village. So any houses in this village is connected with each other seamlessly. So you can see that there will be 1, 2, 3, 4, 5, 6, 7 houses, and there will be six rows in between. So one, two, three, four, five, six. Yeah, I'm gonna delete it. I just want to visualize what I'm saying. So this one. So after that, we're gonna have a query, which for the number of queries, and the next query list is containing the three integers a, b, c, which is like in the problem statement. For each to find the distance from these two houses to any houses inside the village, not including the three houses. I mean, like it's because it's obvious because a the a path the path from a to the same a later houses it will become zero. So I think I don't need to say. So for the output realize, so it's containing the result for each values. So for this each value, we're gonna define we're gonna find the distance from the house ABC to any houses in the village. So we're gonna have this case. So in this case, the n is 4. So we're gonna have 4 houses inside the village, and the UVW indicating the road connecting the houses U and V with the line of W. So we're gonna draw it. So this one is the one, the village one to the village two with the weight of 1. And the next road is from 2 to 3. So we're gonna draw a new house here with a weight of 2. And the next one is from 1 to 4. So as you can see right here, like we have 4 houses which are interconnected with each other. So this row has the weight of 3. So in the first query we have 1, 2, 3 as the 3 houses in for the output of uh, the total distance from ABC to any houses. So this one is 1, 2, 3 houses. So from 1 to from 1 to 3, yeah. From 1 to 2 is equal to 1, and 1 to 3 is equal to 3. From 1 to 4 is equal to, let's see, so release, release. I guess I want to calculate the minimum value. Okay, so here we're not calculating the repeated calculation. I mean, like we're not measuring the repeated calculation. So from 1 to 2 is 1, right here is 1, and from 2 to 3 is, so from 1 to 2 is 1, from 1 to 3 is 3. Oh, actually we don't need to, okay, it's not like from what's the output is 4, 3. The minimum, oh okay, the minimum value, why is the code is three and confusing? So from one to two is three. Oh, oh, yeah, yeah. So it's not from one to three. I think this problem is uh, talking about the pass from one to from ABC to any houses inside the village, but the so I think this problem is not correctly stated. So this means that any houses between this segment of the tree will be calculated. So let's say there will be another road right here, 2, 4, and the 4 is not here. So uh, just imagine I want to explain it correctly because the problem is it's hard to actually understand. So let's say there's a 4 here, the fourth letter, the fourth number of rows. So so if we calculate, let's say uh, we have for 3 rows. So this one we just say one. And, so let's say the first query we have one, two, 1, 4, 1, 3, 4. So that the result will be from one to from two, 1, 3, 4, right? So from one to 4 we have 1 is 2, and from 1 to 3 we have 1 2 is 3, and from 2 4 we have 1, and from okay, okay. So this problem is just delete all things. So I will join it for the test case. From 3 and from 1 to 4 we have the way of 3. So the first variable we have 1 to 3 houses. So we can calculate the distances between them. Yeah, we're gonna calculate the distance between the. No, actually, maybe the output is incorrect. So actually, this problem is if you calculate all the distance from 3 houses to any houses inside the village, and so the problem statement is correct. So on the only wrong thing is the output. So maybe I just make wrong output here. I just put wrong output. Maybe that time I was not awake and not conscious. So okay, so right now the new output is that from 1 to 4 is 3, and from 1 to 1, from 1 to 3 is 3. So from 1 to any houses is 7. 1 to any houses is 7. And from 2 to any houses is, we're not calculating the repeated row. So from 2 to, oh, we also calculate the repeated. So from 2 to 1 is 1. 2 to 4 is 1, 3, 4. So 1 plus 4 is 5. And from 2 to 3 is 2. So 2 plus 5 is 7. We have 7 here. And we from 3 to anything. So 3 to 1 is 3. 3 to 2 is 2, then to 5. And 3 to 4 is 2, 1, 4, 1, 6. So 5 plus 6 is 11. I'm sorry for the inconvenience. So we have 1, 2, 3. So the output is correct. I just misunderstood something in the problem statement. Sorry for inconvenience. So we just try it again. So we have 1, 2, 3 here. 3, 2, 3, and we calculate the 2, 2, and 2, 2, 3. That's it. Even like we're gonna find a row that can connect all these. I mean, the row, this can be not a straight row. I mean, it's not a row, but a way to connect all these nodes of the three nodes together with some number of rows, and recalculating the weights of the sum up the weights between them. So for 1 plus 2 is 3. Yeah, so the output is correct. For 1, 2, 4, 1, 1, 2, 4. Maybe 1 plus 3 is 4. Yeah. So we can see how we can implement the algorithm. Common lowest common ancestor and DFS altogether. So let's wait for some time for me to draw a big tree, so that we can easily imagine. I will also explain it along the way. So just stay tuned. So as I mentioned, we have queries from have three queries consisting of A, B, C, right? So we're gonna have three houses. Let's say this house is A. The this one is B. This one is C. So what is uh the connected path from these roads to interconnect these three houses. So from this will go up to this road, go up and go down to this, and up to the highest node it will go down to this, and this. So the path is here. Correct. Perfect. So um with that in mind, we're gonna see how we solve this problem. So as you can see, which is this node, basically we can like rotate this tree like in some shape. Thus this node will become this node, or this node will become this node, this node will become this node. But this node is not a house. You can imagine it's like uh, the center of the village. So it's not any house there. It's just the center. Maybe there's some store and some shop and not houses. Yeah, so this one is imaginable. We just put it to uh, to like assist our algorithm with the lowest common ancestor and also DFS. So let's see. First we will calculate the DFS to cumulatively calculate the weight, the cumulative weight from one node to this node. So we're gonna traverse this tree like this. So we're gonna have like an array of two dimensional. of two dimension. So we have like this array of two dimension. We start from the node U and with the position of the parents, the nearest low, the lowest common ancestor from the from this node U. So the L is short for level, so the level of the lowest common ancestor. So let's say this one is A. So FA0 is not that is the first common ancestor, and if L is one, this will be this one, and for the two, it will be this with the imaginable node, and also for this one with FB FB 0 is this one, and FB2 is this one, SB1 is this one, and FC1 0 is this one, and FC1 this one, FC2 is this one. So as you can see, what is the performance of that DFS? Let me just say, and I just said, so if the tree, because this tree is not balanced, it depends on uh, the input. So if the tree is one straight line like this, is so each traversal it will become n in performance, but in the best case, it will become log n for each traversal. It will become log n. So we just use the maximum to calculate the performance with n for each traversal. I'm gonna delete this. So like for each FUL is the to pre-calculate the cumulative sum of the weights from A to its ancestor, each level of ancestor. Sorry, um, each level of ancestor. So FUL should be equal to uh, so for this first ancestor. Sorry, I just had a call from, from my class. So this one is ancestor, the first ancestor. So we're gonna calculate the cumulative sum. So so from A to the first ancestor, it will be the weight, the initial weight, and from A to the second ancestor, if of the uh, this one is the W one summed with the W. So the dynamic programming calculation will be FUL is equal to FUL minus 1. And minus 1 is the higher level common ancestor plus sorry, Plus the weight of the current ancestor is L, level L, and from the node U. So this way the formula, and after that we already had for every node we already have the distance from the node to each of its common ancestor cumulative sum. So we already have the cumulative sum of each thing. So let's see how we use the LCA, which is the lowest common ancestor algorithm, to find the nearest common ancestor between two nodes. So we're gonna use I will explain how it works. So we're gonna traverse this tree uh, from this node, like one. We're gonna have a temperature variable right here, and TMP is short for temporary. So we're gonna have this. This one is changed after each traversion. So during the traversion, so from this node to this node, we're gonna increase this by one and put it into a newly created array. Okay, so maybe we can call it a queue. It can be a queue. So we're gonna put this one to a queue. I think just a vector is correct. Yeah, the vector is more correct. Um, so what this one is a vector b, and each time we're gonna push back to this uh, vector. So this one go down to this. We will make the temporary variable to one. So from this to this, we will make the temporary increase to two. So let's say from this to this, it become three. And when once we reach this leaf node, reach the lowest level, I mean like we cannot traverse more, so we're gonna go back because it's a recursive function, so we need to go back. We can also increase the temporary. So for this one, A, when we reach it, the temporary is 3, and when we reach the temporary is 4, 5 and 6, 5 and 6, right? So after that, we're gonna traverse. Let's say we traverse this. We're not traversing anything like this thing, but in real case, we're gonna traverse all the thing. But for summary, I just traverse this kind of branch, and this one to start from 6. In this one, when it reaches 1 is 6. So when it go down, it becomes 7. Become 7, and when it go down, it become 8. So 8 is the so 8 is the tree house, and so if we traverse up, this will be 9 and 10. So let's say We know that these two has a common ancestor, has or not has. I would like you some time uh, to brainstorm how we use this array to find out if these two nodes have the common ancestor. And along with the G, we can look at the G. So we verify this again. So it's not have a new array, array of pair in coins at t, then call it as t, and to the from tu is an array of pair. Tu will store the current temporary variable when it's increasing during the transition. So when it's increasing, if it's increasing down, so this is has for has two variable a and b. That's the pair. It's an array of pair, one dimension array of pair for the a. Yeah, if you store the temporary variable value in that version, in that array that I brought before to the A when it's going down. But when it's going up, it will store in this. So in the same array that I already showed you, you remember that. So in this array, if you store the for the going down, you store in the A, and the going up is for B. So how to find the common ancestor between two blocks with this uh, way of thinking? We check that if the node, if this node is upper with this node, upper means that, let's write this. So upper means the A has a direct straight row to B with the height is higher than B. So A, you see, in this case, A is upper than B, and this had a straight row, had a mean like the proper row, and the B is the subnode in the lower level of the tree compared to A. So it is considered as upper. But how can we know that if A is upper than B? So it's upper to B. So we're gonna look at the T array that we already showed. I already showed before. So we're gonna check if A GB. So as I already said, the TI store the pair of two integers. This is 124, the going down value of the temporary variable during after the conversion. So during the conversion. So the first one is the number from the A. Imagine A is here for easily explaining. So A is here. So let's say it start from the temporary variable 0. So if we start from the temporary number value of 0, this plan is deleted. So start from 0 to 1 and to B is 2. And from B up is 3, is 3, uh, which three, one, 3, 4, 5. So set 5 here. So from B is already the leaf node. So this is 0. And from B, right? So A is 1, 1, 2, and B is going up is 3, 4, 0. So 1, 2, 3, 4. So this is 4. This is 4. And this also 4. So the condition to check if the two nodes is node A is upper than B is rho 2 greater or equal to 0, and as so as the 4 but in different position, the opposite direction. So 4 is less than or equal to 4. And this for A and this for B. So this is the pair number of B, this one is of A, as shown in this case. Okay, you get the idea how to find the upper, to decide which one is the upper, or in another case, none of them are the upper of each other. So with that in mind, if we found that this A here is not upper B because not have a proper way to go, it needs to go through the imaginable node right here. So it's not the upper one. It needs to be here to be upper one, upper, upper, not upper, upper one. So we check if the A is not above B, then we find the nearest ancestor of this A. So I mean like the nearest parent node of this A is this. And then after that we check again. This one is not correct, so this one again come here, again come here. So the common ancestor is here between A and B. So but for this, let's say this one B here, we will find not the upper, we will go here, not the upper, it will go here. So now it's the upper. So the common lowest common ancestor between A and B is this one. So also we gonna use the as I mentioned before, we already have the prefix sum of each node, which contain the cumulative sum of weights from the node to this imaginable node. So this one also. So now we as let's say this in this case B is right here. So the common ancestor is here. So we cannot calculate the distance from A to B. So it's equal to fa common ancestor fa common ancestor to its common ancestor, which is c right here, by c plus plus f f fbc. So the f is the cumulative sum of weights from b to its uh, to its number of parents. So in this case, C is the parents of B, and C is the parent of A, and C is also the lowest common ancestor of A and B. So we will minus to multiply by F FC to the imaginable node with 0. So that we're gonna have the sum, the left sum uh, between A and B. So we may cut this sum, cumulative sum, and we may calculate this one plus this one minus the 2 times because this is a cumulative sum from this imaginable node. So that we're gonna have the distance from A and B. In this case, we only have 3, so we're gonna use this sum, and we're gonna use the lowest common ancestor, and we're gonna find the lowest common ancestor between this common ancestor of A and B to C. So we're gonna find the lowest common ancestor between this one and C, with this one with the same algorithm, the same way of thinking we had before. So that we're gonna find out the this part from A to B and from this to C. So that's it for today problem. Uh, so now I think we can go to the coding process. We're gonna implement it using C++. Go to the algorithm. So in the past video, we are discussed about backchecking algorithm, binary search algorithm, prefix sum and quizsum algorithm. You can check out the videos in the series of algorithm and data structures inside my YouTube channel. So for today's videos, as we already shown, this one is the and OCA, which is for lowest common ancestor. I'm gonna save the changes and we're gonna upload this one. So now let's come to the implementation of our idea and our visualization eventually. First of all, code is the most difficult process. That's why as we practice, we implement ourselves, develop ourselves, get data on day-to-day basis. So that's why it's fair enough. So we're gonna include this stdc++.8 stdc++.8 library. So like the mostly used library for every algorithm issue that I used to join many of gained some prizes. We're gonna use the namespace std, so we're not gonna need to write std like this everywhere my code. So we're gonna use the namespace for more convenient. We're gonna define something. So for this define, we can like shorten our code and make it more readable and not too long. Just like you see, first is like 5 letters, but FS is short for first. There's only 2 letters, 2 characters. Let's see. For the no, because as I already told you, uh, the number of berries and the number of uh, n is really high, so we're gonna use long. We use arrow for long. Actually, we can use another like 2 arrows, maybe arrows because also zero because the n is the n is 2. Oh yeah, the n is 2, so multiply by 5, 10 power by 5, so this one has 50, and 1 is just for making sure that we don't run out. This is the limit of the range with the AI. We short for a pair of double integer. So, error should already divide here. It's long. And L, immediately we can use LI for this loop. So, we use a couple of I. Sick. Now we're gonna initiate some variables. So this function is to store the key value of ABC in each variable. I will find more variables and I will give explanation later. So this for A, C, log. Log. Maybe this is a building function, so we're gonna discuss log. Log. Root, U, A, and B for queries. So we'll modify a pair meaning of inning. This pair is different from this pair because this pair is used for another case. To the following mentioned in the chart. So T and with the length of n is to multiply by 10 divided by plus 1 and multiply values sorry, sorry, with the width of n is a two-dimensional. For the width, it can be n for each u. Like you remember the f function that I already draw previously. So this with the second dimension, this will be we will convert it to integer up to and plus two. So logarithm 2 of n is one of the building function. So I think it's inside this library. So plus two one for the uh for this number two one for the imaginable node is the highest node of our tree, and the one is for ensuring it's not exceeding the limit. So the also for long here answer so we gonna initialize them as 0. So now we gonna make the function and use string with SDO. This can enhance our code performance in like runtime and reduce the runtime. Zero is really a common practice for most of the competitive programmer participants, like competitive programming competition participants. They use this slide to enhance the code performance by 1 to 5 milliseconds or yeah, 1 to 5 milliseconds or something. Maybe more than that, but 5 something. We should go on to the now we're gonna make so this one is the main. I don't want to put everything inside this function, so I'm gonna make another function to process the input and output to another process function. And return it 0. Now actually make this function, not this main function, after all things are done. So now we're gonna make the process function with the main functional function and the primary function. So this is a void function. I'm not going to return anything. I'm not define input of the number and I'm going to do a for loop of from 1 to n from ice from up to 1 up to yes. We're gonna read from the terminal view is the node that start from the starting state with the v is the destination. Here is the weight for the road to the GU is the vector. So that is to store what is the connected houses from the house view. So then we're gonna push back the V is uh, the connected house from the view house. So for GB is like two dimension, not two dimensional. Oh, because G is the yeah, I didn't codify this. G is a vector to pair in it, so that we already define the pair in it. So this, so if we assign to the G the width of n. So G is the two-dimensional vector with the width of n to store from node U to node G to know what are the nodes not connected to the node U. So this one is a two-dimensional. So, assign value for the custom. This one is I think I'm gonna end this video right here. I'm gonna do the second part. So uh, I'm gonna do the second part of this video. So this one is the first part. We already have the main idea behind how to implement, how to visualize the tree and the algorithm of LCA, which short for short the lowest common ancestor, and DFS is short for depth first search algorithm. So let's stay tuned for the next part, which is the second part of this video. So let's see you in the next part.